Hello everyone, we are group 21 and this is our presentation for APS360. So what event changed the world as we know it? No, I'm not talking about the Chris Rock slap. I'm talking about COVID-19. Since the advent of the COVID-19 pandemic, economic conditions have been not so great for the average person, leaving them with limited disposable income. Besides the physical repercussions of COVID, there are also financial consequences. One facet of our economy is transportation. Everyone needs cars for their jobs and for their daily living. And a private car is something more and more people are opting for recently. Having said this, there's a gap for an effective used car price estimator for consumers, which is exactly what we are proposing, a car price estimator. People can use our model to estimate how much they can sell their car for, or are they getting a good deal on a used car? And the reason that we're choosing to do this project is because there doesn't exist a one-size-fits-all program that considers all the different attributes such as age, condition, mileage, and cars are always being manufactured and data is always being added. So that's why we thought machine learning was appropriate, and hence our model. It identifies trends and patterns within the data and requires minimal human interaction. Next up, Phoebe will talk some more about our data set.
Thanks, Nick. So our original data set was from Kaggle, and it contained the listing prices of over 7,000 vehicles from the UK, along with many other important details such as the model or its manufactured year. It was also last updated on January 30th, 2022, which meant that we wouldn't have to worry about inflation, and we would have all the details of more recently manufactured car models. Now, because of the fact that these were UK listings, we needed to first convert all the prices from pounds to Canadian dollars and any empirical units into metric ones. We also discarded any Vauxhall or Skoda vehicles, as these brands are not sold here in Canada. Finally, we resplit the original training and testing data in order to have our new validation data set. We kept the percentage of the different features consistent across all three data sets, and the three graphs you see here on the bottom are just an example of how we kept the three brands proportionate across all three data sets. So as you can see here, the listing price fluctuates greatly depending on what specific feature you're looking at. And with so many different features and inputs, both in string and numerical format, we decided to convert our data into one-hot encodings in order for our models to find any kind of patterns, which Oltan will be speaking more about this in detail.
Thanks, Cindy. So for a model, we have chosen the random forest, which operates by constructing multiple decision trees, and in the case of the regression problem, taking the average of all the trees as predictions. We chose random forest as we found it to be the best suited for a problem, which has a large data set and a large number of features. Here are the hyperparameters of the model. We chose the two. We have the number of trees in the forest, which, to give you an idea, we chose to be around 1,000, the loss function used, and the maximum depth of the decision trees. I will now provide a demonstration of our model.
So here I am on our Google Colab. As you can see, I have trained our model with our final hyperparameters, and I pulled out some test data which the model has never seen before in its training. Here you can see the cars with their features and their actual prices. So what we do is we turn the input into one other coded and put it into the model, see what it outputs. And here, as you can see, here the model's predicted prices for the cars respectively. And from the looks of it, our model is performing really well.
Stephen will now talk about the results of our testing.
So, as per problem stated earlier, this is a clear regression problem where we're fitting a model or a function to a dataset. So there are three measures of performance that we're using to determine if our model is successful. First is the R2 score, or determination coefficient, which is a measurement of how well the dataset fits to our predicted outputs. Our root mean squared error, which is just a representation of the standard deviation of differences between the predicted and actual values. And finally, the mean absolute percentage error, which this is a percentage of average absolute difference between the actual and predicted values. So we have three different model types to compare results. I'd like to draw your attention to our final model, which is a random forest. And as you can see, it scores a better R2 score for validation training set and a better MAPE for validation as well. It also scores slightly worse on training when compared to the decision tree regressor. However, before we're able to overfit close to a perfect value. And then for the decision tree regressor, we scored better on the training data set for all metrics. However, it did worse on validation scores, which potentially indicated some overfitting. And then for the linear regressor, it scored the worst in almost every category and was severely overfitted on the training data set. We expected this since there's a decent amount of features in this data set. So after we put them into our random forest model, you can see the predicted prices that our random forest gives on the right column. And I want to bring attention to the third row. And you can see that the prices itself differs by about $10,000. However, the actual absolute percentage difference is only about 11%, whereas every other value in the table differs by less than 6.6%. This is important to take into account because the differences between the predicted prices are in the order of magnitude of 1,000s or the thousands. And therefore, the MSE itself would generally become a bit higher when we think about how our model scores. However, the actual percentages themselves are all pretty good, which indicates that our model is doing a pretty good job predicting the values percentage-wise. So some takeaways. Affordable and accessible transportation is incredibly important in a world that has been affected by COVID-19 and where workers are commuting to offices again and might not have access to new cars. And by our measures of performance, we believe that our final model is well suited towards all types of used car data sets and will fill our gap well. Thank you for listening to our presentation, or thank you for listening. I hope you enjoyed our presentation.